Welcome back, and today we're talking about finding the equation of a line. There's going to be four different scenarios. The first one we're going to look at is if we're given the slope and a point. And when you're asked to find the equation of the line, you have to know two different forms. The first one, of course, is our slope-intercept form. Just to review that one. That is slope-intercept form is y equals mx plus b. You should be familiar with that guy. And today we're going to talk about point slope form, because to solve or find the equation of a line given the slope in one point, we are going to use point slope form. And then isolate y. The reason why we want to isolate y is because that gets it back into slope-intercept form. And point slope form might be new to you, so we're going to write it down real quick. Point slope form. That is not working the way we want it. Boom, there we go. Point slope form is y minus y1 equals m parenthesis x minus x1. And you might say, oh doggies, that looks a lot more complicated than y equals mx plus b. But the thing we got to understand is with this situation, the x1 and the y1 is a given point. The m is your slope. That's the same as our other formula. And the x and y stay x and y, okay? Those guys stay variables. We don't play with them. And the reason is because y equals mx plus b, you're going to have a value for your m, a value for your b, and your x and y stay variables. So I'm going to do two examples real quick for you. Again, if you need to pause this and write down that formula, that might help. And here we go. So example 1 is if you're given -4, -3, and your slope equals 2. We're going to use our point slope formula, which is y. Before I keep going, y minus y1 equals m parenthesis x minus x1. Before I solve this problem, why do we call this guy point slope formula? Because it's got a point in it and the slope. How about that? And if you look back here, slope-intercept has the slope and the y-intercept. So these names of formulas are very descriptive. All right, so here's our point slope formula. We have our x1, our y1, and our slope. Remember, x and y stay just what they are. Just x and y stay variables. And we're going to substitute values in for y1, m, and x1. So we have y minus y1, -3, equals m is 2, parenthesis x minus x1 is -4. Boom. Once you get to here, you are going to do 3 steps. And you always do the same 3 steps once you get to this point. You eliminate any double negatives. We have a double negative here. I'm going to turn that into a big plus. And a double negative here. I'm going to turn that into a big plus. Okay. Then I distribute my slope. There's my slope. I distribute that. And now I have y plus 3 equals 2 times x, or 2x, and 2 times 4, which is 8. And last but not least, I isolate my y. So I minus 3 both sides. And now I have y equals 2x plus 5. Ta-da. And you'll see right there, hey, our equation is back into slope-intercept form. That is the form that's usually preferred on these problems. Okay, I'm going to show you guys one more. And next page. This one is going to have a fraction. So what if we're given a point like -5, 1, and we have a slope of 1/5? Oof, that could be tough. Remember, you can use calculators, of course. x1, y1, there's your point. And now we have y minus y1 equals m parenthesis x minus x1. And we substitute all these values in. Y minus y1 equals m parenthesis x minus x1. Boom. Okay. From here, Three-step process. Eliminate double negatives. Bop. Distribute your slope. Remember, this part might look complicated. 1/5 times x, it's just 1/5 x, guys. 1/5 times a 5, if you don't know how to do that, use a calculator. It's 5, though. Or it's 5 over 5, or just 1. And last but not least, we need to isolate our y. So we're going to plus 1 both sides. Get our y totally by itself. And we have y equals 1/5 x plus 2. Where's my eraser for that guy? Boop. Plus 2. Boom. That's it. Thanks for watching. Hope that helps. We're going to have videos on the next few types of problems as well coming up. Have a good day.